Let's get into the acid and base math. That's kind of tough to say. First of all, I'm going to give you a resource sheet. And yes, you get to have a clean one on the test. What I want you to notice is that you need to pick the correct equation when you're doing the math, okay? What do I mean by that? If I am asking you to find the pH, choose the equation that starts with pH. If I'm asking you to find pOH, use that equation. If you're looking for the concentration of H, there's your equation. Concentration of OH, there's your equation. These two equations allow you to alternate between pH and pOH. What do I mean by that? Well, sometimes I might give you the concentration of H and ask you to find pOH. And by the way, there is more than one way to do these problems, and that's okay. You're going to get the same answer. Me personally, I would probably turn H into pH and then use this equation to turn pH into pOH. So there's different ways you can do this. And we'll talk about the M1V1 equation later on when we get to titrations and whatnot. But I want to point out something else awesome about this sheet I'm giving you. I tell you exactly how to put it into my calculator, okay? So for pH, you're going to type in the H concentration, and then you're going to press log. Don't forget, you're going to have to do scientific notation. You need to use the EE button. If you don't, you're going to get a weird answer. But why is there a negative on these two equations? Well, every time you use the log button, you're going to get a negative answer. We don't want a negative pH. So the negative times a negative is a positive. To be honest with you guys, I plug in the H value, I hit log, and I just ignore the negative sign, all right? One other weird thing about sig figs, when you have a number like this, okay, we know that is 2 sig figs. The way that translates into pH is the number of decimal places, not the whole thing. We don't care about the first number. We just care about decimal places. So I'll help you through that as we work through our homework. So here's the homework assignment you're going to do, okay? And I just want to do a couple with you. Maybe I'll do a little bit of it. Maybe I won't do all of it. But you need to, on this first one, you need to take H and find the concentration of hydroxide. You want to find the pH, you want to find the pOH, and then decide whether or not it's acidic or basic. So many ways you can do this, you guys. You can go straight to OH by using this equation right here. Just take the 1 times 10 to the negative 14th and divide it by the H. Or you can take the H concentration, go straight to pH, use this to get pOH, and then work backwards to get the OH. It really doesn't matter. I'm going to first do 1 times 10 to the negative 14th equals 7.5 times 10 to the negative third. If my marker will work here. Times the OH concentration, okay? So on my calculator, 1 EE 14 negative divided by 7.5 EE 3 negative, and I'm going to get 1.3 repeating times 10 to the negative 12. 2 sig figs, right? So this will be 1.3 times 10 to the negative 12th. To do pH or pOH, it's the same exact thing. Let me clear some of this out here, okay? You're just going to plug in H, hit log, ignore the negative sign. So I'm going to type in 7.5 EE3 negative, press log, ignore the negative. Now, 7.5 is 2 sig figs, so I want to go to 2 decimal places. So this is going to be 2.12. And I can either use that same equation to get pOH, or you guys, it's just 14 minus 2.12. So that's going to be 11.88. I hope. Better check that, huh? Yep, 11.88. All right. So now, as far as whether or not it's acidic or basic, what you want to do is you want to compare these two columns. When H is greater than OH, it's acidic. When H is less than OH, it's basic. And of course, when they're equal, it's neutral. So I have 7.5 times 10 to the negative third versus 1.3 times 10 to the negative 12th. Yeah, H is way bigger, so this is going to be acidic. There's way more H's than OH's. So that's how you do that whole table. And then I gave you another table to practice on. It's basically the same thing, okay? Now at the bottom, let me erase this stuff here. At the bottom, I just want you to review acid base, conjugate base. Recall that on this side, on the reactant side, they're just acid base. On this side, they're conjugate acid and conjugate base. Really, what I would suggest you do is that you look and see what happens. So look at the first one. NH4 plus becomes NH3. What happened to it? It lost an H. Acids lose H's. So if that's the acid, this is now the base. And because it's on the product side, we just throw the word conjugate in front of it. This one gained an H. That makes that the base. Now it has an H to give away, so it's the conjugate acid. And that's all you have to do on these. Very, very, very simple. But you do need to get used to using these equations, using that log button. The other one that's kind of odd is this equation here. Let's just take a look at it. You're doing 10 to the negative pH. Just trust me, you guys, I did the algebra from this equation to here. What you want to do is type in the pH, press the plus or minus button, press second log. That is how you do it on the calculator, okay? It's really not that difficult. And don't forget, sometimes we need to bounce back and forth between scientific notation. Second and 5 puts it into scientific notation, while second 4 takes it out of scientific notation. It's really, really handy. You might want to try and do that quite a bit. So go ahead and give this a try. It's not a very difficult or very long assignment, and feel free to check your answers when I see you again.